Okay, students. So in this video, we'll discuss about measures of central tendency. So I'll just put it up like this: measures of central tendency. So what are measures of central tendency? See, these are the measures which helps us locate a central portion of a data. For example, if there is a data, what do you mean by central tendency? It's simple, right? If there is a number which can represent the entire data, that's called a central tendency. And that number is generally towards the center of the data. For example, if I just plot data points over here, for example, I'm plotting these data points. These are all the data points on, let's say, two dimensions, y-axis and x-axis. Let's say now the central tendency is something like this. This particular part is my central tendency, right? If you look at it, this is my central tendency. Now this is kind of taken as a representative of the entire population. If you look at the entire population, this is the entire population, right? It's the entire data, right? So the central tendency is kind of a representative of the entire population over there, right? That is central tendency. Now central tendency have three kinds of how should I say it? There are three types of central tendency. There are three ways in which I can find the center of a data point, right? Or I'm sorry, I'll rephrase that. There are three ways through which I can find the central tendency of a data. For example, let's say age of all the people. Okay, so one is of course mean. The other one is median, and the third one is mode, where mean and median are the most commonly used ones. Mean also have three kinds of mean over here. One is AM, arithmetic mean. Then we have something called as GM, geometric mean. Then we have HM called as harmonic mean. Mostly we use something called as arithmetic mean over here. Okay, so let's try and understand what do you mean by this. All right, let me start with mean. Okay, let me start with something called as mean. What do you mean by mean, which is also taken very conveniently as average when it is not equal to average? There are other elements over here, but before we move on to this, or probably we can just start with AM, the first one, which is arithmetic mean. Arithmetic mean is our average, right? This is our average, right? And also average also are of two types. One is the normal average, the other one is weighted average, right? So we'll discuss it over here, right? What a normal average? Normal average is, let's say if I'm given the let's say age of 10 students in my class are like 10, 13, 17, 19, 20, 23. How many of them are there? 6. And then we have 24, 24, and then we have 25, and let's say 30. Now if I have to take the average of this, okay, so what I need to do is to sum all of them up and divide by the number of quantities, which is 10 over here. So if I sum it up, if I quickly sum it up, it will come out to be equal to 25 plus 17, 42. Then we have 61, 81, 104, 128, 148, 152, 177, and finally we have 207 comes out to be the summation. So the average comes out to be 20.7. Now my next question is, this is the normal average. So the formula over here is average or arithmetic mean is nothing but sum of quantities by number of quantities. Very simple. This is my, let me do it properly. Yeah. So this is my formula for average, normal average, sum of quantities by number of quantities. Weighted average, however, comes in with, say, let's say I talk about few subjects over here. Let's say the subjects are A, B, C, D, and E. And let's say the marks scored by me in these 5 subjects are, let's say, 91, 86, 77, 82, and 91. Okay. Now let's say these are the marks scored over here. If I had to calculate the average over here, average will be very simple, adding up them right? Adding them up and dividing by 5 will give me the average marks over here. If I do a bit of rough work, let me change the color of the pen. Let me do a bit of rough work over here. So 9 plus 8, 17 plus 7, 24 plus 8, 32 plus 9 comes out to be 41. So 4 and 10 plus 7 plus 7, 14 plus 3, 17. So it will come out to be equal to 427, comes out to be the sum divided by 5. It's going to give me what? 85.4 comes out to be my average, the normal average over here. But if I introduce something called as credit, okay, what are credit? Credit is nothing but the weightage or the importance of these subjects. Something like, let's say the credit of this subject is 3, this is 2, this is 1, this is 2, and this is, let's say, 3 again. Okay, now will my average marks come out to be same as 85.5? I doubt that. It will not come, because now if I just sum up the quantities and divide by the number of quantities, just like I have done over here, I have by default taken the weights of all the items involved over here, all the quantities involved here, same. Right? It need not be the case, right? The weights might just be different. Okay. So here what do I need to do? I need to multiply this by the weight. And I think I should give you the formula. I'll just change the name, color pen. And I get weighted average statistically is nothing but sigma of product of the weights multiplied by the quantity, respective quantity, divided by sum of the weights over here. I starting from the first quantity going up to nth quantity. Same is the case over here. I starting from the first quantity going up to the nth quantity. This is the formula for weighted average. Allow me to explain. So it is weight of the first quantity multiplied by the first quantity, weight of the second quantity multiplied by the second quantity, weight of the third quantity multiplied by the third quantity, and so on. I mean, how many quantities are there, how many weights are there, divided by W1, W2, and W3, and so on. So this formula, you can see weighted average is nothing but equal to the formula for 3 quantities with their weights. It might be 5 quantities with their weights, it might be 10 quantities with their weight. It's just that sum up all the products of weights and the quantity. For example, if I just do it, I'm not left with any space over here, so I'll just do it over here. So 91 multiplied by 3 will be equal to 273. 86 multiplied by 2 will be equal to 172. 77 multiplied by 1 will be 77. This is 164 and this is 273. I'll again do the addition very quickly over here. This is my rough space. I'll just clear it up a bit. Right. And I'll start doing the calculation over here only. Okay. Now 273 will be nothing but 200 plus 100 plus 100 plus 200. It's going to give me 600. The first thing is 600. Okay. I'm just summing them up. So this is 273 is nothing but weight 1 multiplied by quantity 1. Weight over here is 3 and the quantity is 91. Right. So 300, 600, 70, 70, 70, 210, another 70, 280 plus 60 is 340. Fair enough. And then I have 3 plus 2, 5 plus 7, 12 plus another 7 is 19. Comes out to be 959. So the numerator over here comes out to be 959. Divided by the sum of the weights, and the sum of the weights comes out to be, I'll just do it red, it'll be 5, 5, 10, 11. So this 11 comes in over here. Alright, so it comes out to be 959 divided by 11, which will be equal to 11 8 is 88, 7 9 11 7 is 77, 2 is 1, 90 is 87.18. Now it is significantly different from what I found over here, right? It was 85.4 if I recall it correctly. It is different because the weights are different. That is the meaning of weighted average. Now let's move on to the real meaning of average and what is the application of average over here. Okay, so we'll see that. Okay, so till now we have understood that mean is nothing but there are 3 values over here. One is arithmetic mean. We have just seen this arithmetic mean. Then we have something called as geometric mean, and there is something called as harmonic mean. Well, these two are applied not that frequently, but still are important. Geometric mean is, GM is nothing but nth root of all the quantities, that is A1, A2, A3 multiply till an. So nth root of product of all the n quantities over here. For example, if there are two quantities, right? If I go for, if there are two quantities, then geometric mean will be written like this. GM will be equal to square root of A into B. Let's say the two quantities are A and B. If there are three quantities, then I'll write GM as nothing but equal to cube root of ABC. If there are four quantities, of course, GM will be equal to nothing but fourth root of A, B, C, and D, and so on like this. It depends upon how many quantities are there, right? Now, GM is very, very applicable when it, if I just talk about the application of GM, right? Let me change the color of the pen again. The application is something like this. For example, my money, let's say I'm invested it in an instrument, and that increase my money by 10%, 12%, and let's say 13%. Oh, these are very simple numbers over here. Let me go for a twist. Let me say that my money increased by 10% in the first year, it increased by 12% in the next year, and in the third year, unfortunately, decreased. It just increased by 8%. Let me not go into decrease right now. It just increased by 8%. The first year it was 10, second year it was 12% increment, and third year it was 8% increment. What is the average percentage increment in my money across the years is the question. Now people have a very simple habit of taking the average over here. It will be 10 plus 12 plus 8 divided by 3. So it's good for approximation, but it's not exact. It'll be equal to 20 and divide by, oh, nice. It'll come out to be 30 divided by 3. That helps, isn't it? So on an average, my money grew by 10%. But this is not the correct statistical approach or mathematical approach. Why? Because percentage is not a standalone term in itself. Percentage is nothing but, when I say 10%, I'll say 10% of what? Right? It is not a standalone term. It is relative. That is, it is of something. So are you saying that 10% every year? Are you saying that 10% every year? Then in that case, it's not correct. Here, geometric mean comes into picture. Now, if you look at it, the geometric mean, I can say that can help us understand the overall rate. The first year, my money became 110% of itself, because 100% तो पहले ही था, 10% से बढ़ गया, it becomes 110% of itself. Then it became 112%, and then it became 108%. So I can say that 110%, 112%, and 108% are the three factors which got multiplied over here. Now, if I just calculate the factors, I'll get 1.1 multiplied by 1.12 multiplied by 1.08. Okay. Let me just do the calculation over here. Let me use Excel over here to compute the values over here. Okay. All right then, so I just opened up a simple Excel. So the three numbers are 1.1, 1.12, and we have 1.08. I need to calculate the geometric mean. As there are three numbers, I'm looking forward to multiplying these three, which is like product of these three, right, and them raised to the power of 1 by 3. It's cube root, isn't it? Now, if I do this, it'll come out to be 1.099879. Okay, let me get back to my dashboard over here. Now, this is how much was it? 1.99879. So I'll do it. 1.9, whoops, not 9, 1.099. My bad. 099879. So I can say that the money almost increased, became 109% of itself every year. So I can say that the rate was not exactly 10%, it was close to 9.9%. Now, as the numbers were very close to each other, my approximated average and the real geometric mean average comes out to be quite close to each other. But if I make it like 10%, 23%, and 42%, the difference will be significant over here. Okay. That's geometric mean. That's the application of geometric mean. Similarly, we have something called as harmonic mean. Let me see the definition over here, and perhaps we can move on to understanding it separately in the separate sheet. Harmonic mean of a quantity is nothing but the number of quantities divided by sum of their reciprocals. Right. However, number of quantity, however be the number of quantities, harmonic mean is nothing but equal to number of quantities divided by sum of their reciprocals. That is the meaning over here. Okay. Right. So, for example, if I had to calculate HM, now I'm not left with any space over here. I probably use this particular portion and I'll use the red pen. Now, if I had to calculate the harmonic mean of two values, let's say 45 and 60, the harmonic mean will be simple. Harmonic mean will be equal to number of quantities 2 divided by sum of their reciprocals, which is 45 plus 1 by 60. Again, this will lead us to some calculation. I'll use Excel over here. Right, I'll come back and I'll say 45 and 60. 45 and 60. Let me see, do we have a direct formula to calculate harmonic mean? So I'll go for, yes, there is a formula to calculate harmonic mean. All right, I'll calculate the harmonic mean of these two and it'll come out to be 51.42. So it comes out to be 51.42. Again, if I take the average, it'll come out to be, if I take the average, straight average, 60 plus 45, 105 divided by 2, the average comes out to be 52.5. Right. Now, what is the application of harmonic mean? Let me, when do we apply harmonic mean? Whenever we are actually dealing with not quantities but rates. For example, productivity at a shop floor, speed of a vehicle. These are all nothing but rates. I cannot just add the rates or take the average of rates over here. What I need to do, if I need to combine two rates over here, I need to go for something called as harmonic mean. For example, I have two shop floors in my production factory. The shop floor 1 gives me a productivity of 45 units per hour. The shop floor 2 is going to give me a productivity of 60 units per hour. What is the overall productivity I'm achieving in the entire shop floor? Then in that case, what we need to do is to take the harmonic mean over here, not the entire average, because I don't know what is the strength, how much is the shop floor making. Here, harmonic mean is basically a better approximation of the average. So on an average, my factory is producing 51.42 units per hour. That's the point, right? That is the entire objective of harmonic mean. So guys, these are the three means. In the next video, let's try and understand what do you mean by median and mode. I think we'll cover median and mode in the same video. See you guys there.